Hello everyone, welcome to chapter 11. In this chapter, you're going to be introduced to the very last significance test of this book, and let's get started. So first section, it's a very general overview of chi-square test, and you'll be introduced to chi-square golf test. You typically use chi-square test when we're comparing multiple categories of data, and we use chi-square because it simply doesn't make sense to do the one sample z-test or two sample z-test multiple times and compare each category individually to see if they're off or not. With chi-square test, you only do it once, and you kind of have a very general overview of whether the data are off or not. So here's the example from your book, the M&Ms count and everything. So if you're doing a one sample z-test, what you're gonna have is, as you can see right here, you have the sample proportion, which is 15% for the blue M&Ms, and the company claims they have about 24% blues, which is a bit off. And then you're gonna do the one sample z-test for blue. As you can see, you have the alternative and the null alternative hypothesis here. However, it's only for the blue, right? And you're going to do again for the orange, for green, for yellow, for red, and brown. That's 6 tests. Of course, in the actual AP exam, I'm not going to be able to do that. Which is why you're going to be introduced to chi-square test right now. And as I just said, introducing chi-square goodness of fit test. So for chi-square goodness of fit test, you have kind of different ways to state your new and alternative hypothesis. For example, the first two, your new and alternative hypotheses are stated in words, as you can see right here. Or you can still do the mathematical thing, and as you can see right here, you're going to state P equals to 0.24, P equals to 0.2, and P that, etc. And then you kind of still put words for the alternative hypothesis if the case applies. And please remember, you are always comparing the observed count with the expected count. And this is the whole point of the chi-square test. You're just comparing what the data is supposed to be and the actual data you actually got. And now is the equation for the chi-square test, or the actual chi-square value. This is what we calculated right here. The observed minus expected square over expected. And to get expected value right here, how do you get the expected value? All right, how do you get the expected value right here? Okay, it's very simple. In this case, the example we just took, you can go back if you need to. You just use the population proportion times the actual count, or the total count, to get the expected count, because that's what's in the long run. And now, what shows right here is a very good graph or actually a very good picture, in this case, of all the components of the chi-square for this particular example. As you can see right here, you're calculating the chi-square for each different category and just add them up, and you get this number right here, this magical gray number, 10.180. That's the chi-square value. And of course, we're learning the significance test. It's just a single chi-square value does not give us anything. You have to do the p-value test. And before we do that, actually, you have to learn the degree of freedom. Oh, I did that again. The degree of freedom is the number of categories minus 1. This is kind of tricky sometimes, but I mean, if you memorize it, it actually kind of became just a sixth sense. And please note, during the test or quizzes or tests or the actual AP exam, if you're drawing the chi-square the graph, it is very tricky because it's different with different degree of freedom. As you can see, it's not like the normal curve. You just draw the little bell-shaped thing. This one actually varies with the degree of freedom, as you can see right here. Degree of freedom of 1, of course, is the most tricky one because it's just a decay line. When you go into 4, you're gonna have like a kind of bell-shaped, but it's still different. It's very skewed. And on the graph, on the right, that's where the p-value is. And your chi-square, the number you just did right here, number you just did just now, that's where it is on the graph. And it's always the value on the right side under the curve. And that's the p-value of the area. And for chi-square tests, you're checking 3 conditions. It's random, large sample size, independent. The only difference between the chi-square test conditions and the normal test conditions is that you're gonna have large sample size instead of normal. But if you really think about it, it's always about the counts. The counts. For example, the normal is 30, and here you need 5 for the expected counts. And here is straight from your book. This is a very general overview of what I just talked about. I suggest to pause the video and just go through this real quick, and just to review and kind of help you memorize what you're supposed to memorize. And now here's our example, the actual example from the book. This is testing whether the births are evenly distributed over the week, and you have about 140 births that you have collected, and even the number of births for each day: Sunday, Monday, Tuesday, all the way to Saturday. And of course, we're going to do the 4-step process: stay, plan, do, and conclude with the annoying process. Of course, you just have to do it on the actual AP exam and for each of these tests and quizzes, so you can pass this class. Okay, now let's get started. State, you're going to have your new hypothesis, alternate hypothesis. In this case, it's just written down. And of course, you can also just have the option of using the words, mathematical terms. Of course, it seems shorter, but please remember, in the actual test, which is not presented in this example, you have to kind of state what P stands for. What does P mean? And again, you're gonna have to say P stands for the proportion of birth of each day over the week, over the total over, yeah. So you kind of get the idea. Which my point being, though, if you're using the mathematical terms, you still have to kind of write something down. So why not just write down the whole thing, the null alternate hypothesis in words? You don't have to define again. Well, it's all your choice, of course. Now we move on to plan. Like I said, random, large sample size, and independence. And the do process, very typical, very easy. Easy to understand. That you have the chi-square of each component is written down, and they have this magical number right here. You're gonna graph it. Well, of course, always check the graph on your calculator, and now you have the p-value right here. And like I said, of course, you can use the calculator and just get the answer straight. Chi-square CDF. You put this data in, gives you the p-value. And always remember to have the conclusion, which of course everyone knows very well, but should know very well by now. And of course, if you really think about it, the chi-square test kind of compares all categories together at once. So, which in some scenarios, you might have certain categories that are actually very accurate, whereas the other ones just not. But which is why you have to show the components of the chi-square test. The components, like I was always talking about components. I was underlining all these numbers. All of those numbers are components. These individual chi-square for each category are the components, and it is better if you show them. And you're certainly gonna use them later for the follow-up analysis. And now let's finally move on to section 2, the last section you're gonna learn about. In this section, you're gonna learn about the homogeneity and the association independence. Like I said before, you only use chi-square when you have multiple comparisons of different categories. And first of all, you're gonna do an overall test to see if there's a good evidence of any differences among the parameters that we want to compare. And then, like I said before, a detailed follow-up analysis. You always want to include the follow-up analysis in your at the end of your test, either Mr. Lee's test or quizzes or on the actual AP exam, because, like I just said before, the chi-square test is very generalized, and you just want to show the reader that you understand which categories are actually affecting the entire all the categories that it's with, and this hypothesis is for the homogeneity one, because there's just no difference and the difference, and it is very obvious. Homogeneity means not different or the same. Of course, in the new and alternative hypothesis, you're going to say no and different or not different. And finding the expected count is always a big thing when we're doing the chi-square test. If you remember, on one of the conditions is the large sample size, and that's the expected count. Your expected count has to be over 5 for each categorical number. Of course, you can always find the expected counts on your calculator. The book actually shows you. It is not included in this video, but you can always check your book. It's very detailed and very self-explanatory. You should be able to get it. Let's go back to the what we're talking about right here. You're going to use the column total times the row total over table total. Like if you notice the red little boxes right here, you just times 999 times 84 over 243, and you'll get this 34.22, and that's the expected count for the French wine bought with no music playing. So that's this one right here. Yeah, it's this one right here, no music playing. And remember the conditions: random, large sample size, and independent. And now we're gonna actually go into the homogeneity test. And again, straight from the book, it'll be great if you pause the video and actually go through this real quick, just to review what we talked about so far. Another example from the book. So this one's comparing different kind of they're trying to kind of find out whether if the different survey, if you're using a cell phone or using a landline phone, if that gives a different result of the political preferences. So stay plan, do, and conclude. We understand you hate that, but you just have to do it. So state, as you can see right here, since it's a homogeneity test. Actually, let's go back real quick. So in the question, actually kind of it's pretty clear. Just give me 1 second, please. You know what? Never mind. But anyways, since it's a homogeneity test, you're gonna have the difference and difference whatever. Have plan, random, large sample size, the independence, and you're gonna have the do right here. And again, these are the each one of those are the components, and of course you're gonna use this on the actual test when there's just simply too many components. You just do this, and since you can check the components on a calculator, which will certainly show you later, and just make sure you have the number right. Just use the calculator, guys. Just use your calculator. Don't do by hands. What you do on the test is you write down the generalized equation, and then just plug in the numbers real quick. And in this case, we can even kind of skip couple ones, and make sure you get this number right from the calculator. Don't do it by hand because you might just get it wrong. And degree of freedom, again, I think I skipped that in the previous. In the previous slides. Degree of freedom of homogeneity when you have multiple categories is you times the row total minus the row minus 1 times the column minus 1. Number shouldn't be confusing in this case. And then again, you have the p-value right here, and you just conclude. And please remember the follow-up analysis, please, guys. Like I said, since chi-square is a very generalized test, you always want to show which category is really contributing to the big chi-square or the low p-square p-value. And it's very simple actually. Just read this text real quick. You're gonna find the components on your calculator, and just find the biggest number and write it down. Just identify it. The follow-up analysis is should be only 1 or 2 sentences, just explaining which category it that's contributing to all the differences, and you'll be all right. And now let's talk about association and independence. It's the last part of this. So the new hypotheses is, of course, when we talk about association, you have association right here. Association. It's pretty self-explanatory. And then we have independence, and then again independence. Oh, I'm sorry. Independence. There you go. And again, here's from the book. Since association / independence are very similar to the homogeneity test, the only difference is you're kind of concluding differently, and your new alternative hypotheses are going to be a little bit different, but the whole procedure is the same, exactly the same, because you're still going to have the chi-square. You're still finding the p value the same way as you did for the homogeneity. It's only the wording, guys. It's only the wording. It's not that hard. And now it's an example. And this example, look at this right here. This association, right away, it's association test. And follow-up analysis, guys. So stay plan, do, and conclude. Again, I understand you all hate that. You just gotta do it. And during your new hypothesis and alternative hypothesis, association, guys. And plan random, large sample size, independence. Large sample size, you can get the expected count from the calculator, and just make sure they're all above 5 or at least 5. And do, as you can see right here, it's exact same thing with from the homogeneity test. You're just showing the same thing all over again. The only difference is the way you explain it and the way you explain the alternative hypotheses. Okay, guys, so that's the very last slide. Oh, look at this, 12 a.m. right here, guys. Well, thank you so much for your patience, and hopefully I'll get a 5 on the actual AP test. This is all I can do for you, and thank you for your time and patience. Thank you very much, and goodbye.